good morning, afternoon, or evening. How y'all doing today? Welcome back to Mr. Morrow's Honors Geometry class. Today we're going to wrap up Chapter 7 by talking about regular polygons. Now, we've already talked about regular polygons a little bit. Pretty much you know what they are. Regular polygons are polygons that have equal sides and equal angle measures. That's what a regular polygon is. Okay? It's different than saying equilateral or equiangular. Remember, equilateral just has all equal sides. Does that necessarily mean that an equilateral polygon has all equal angles? Guys? No. Give me one quadrilateral that's an equilateral but not equiangular. A quadrilateral. Triangle's not a quadrilateral. A rhombus, yes, very good. And by the way, a triangle would be equiangular. Okay, but that's okay, no big deal. So a rhombus is a quadrilateral that is equilateral but not equiangular. So regular is different than that. Regular polygon has all equal sides and all equal angle measures. I gave you just a bunch of different regular polygons here. The first one being a triangle because it has 3 sides. This is a square, okay? So if it was a square and it's regular, that means that all sides are congruent and all angles are congruent. This is a regular pentagon only if, though, all sides and angles are congruent, and it keeps going on down the line. Got a hexagon, a heptagon, octagon, nonagon, decagon, okay? I'm not going to draw the tick marks for all of them, but you get the point, hopefully. Regular polygon means that it's a polygon that has equal sides and equal angle measures. The regular polygon exterior angle theorem. Very simple and very easy. In order to find the individual exterior angle measures of any regular polygon, use the formula blank. Let's think about this for a second. What's the total angle sum of the exterior angles of any polygon? 360. So how do you think you'd find the individual angles? You're very close. I'm very proud of you. It's 360 divided by n, right? Because if I have 360 degrees as the exterior angle sum of any polygon, if I divide that by n, that means that n is the number of sides, right? The number of sides and number of angles, correct? Remember that when we're talking about exterior angles, I can only have one exterior angle at every vertex. So if I divide that 360 by the number of sides of the polygon, I get the actual individual exterior angle measures. Yes, sir? Same thing. Same thing. What he had said is n times x equals 360, but we're identifying E as the exterior angle measure. Now, give you a little example here, okay? This is an equilateral, and it happens to be an equiangular, because that's the only type of triangle that you can have. It's equilateral and equiangular. This is a regular triangle. I have one exterior angle at every vertex, okay? So I can do this one of 2 ways, and I like to show this because sometimes we forget, sometimes we get nervous. We are human beings, okay? It happens. But I want to give you 2 tools for this. The easy way to find the exterior angle measures, the individual ones here, is 360 divided by 3. It's 120. Definitely use that, my brothers. That's the easy way. The other way, once I know, okay, it's regular, okay? So I can find the interior angle measures very easy. N minus 2 times 180 divided by n, right? That gives you the individual interior angles. Well, aren't these 2 guys supplementary, y'all? So wouldn't this have to be 120? And since they're all interior angles are equal, it's regular, That would be 120. That would be 120 as well. So you could find it the long way by finding the interior angle sum measures, the individual ones. Okay? And then just go ahead and remember that they're supplementary to one exterior angle at every vertex. But the easy way, and it's not that difficult of a formula, is 360 divided by n, where n is the number of sides. Does that make sense, gentlemen? Pretty simple, right? That's the lesson. Okay, that's it. Easy peasy. Find the exterior angle measures of a regular heptagon. Okay. How many sides in a heptagon? 7. So, 360 divided by 7. Okay. You can use a calculator. So it's going to be 51 point something here. Let's see, divided by 7. 50, very good, sir. 51.428. We could estimate that to be about 51.43. Now, degrees. Someone may say, wait, hold on, Mr. Morrill. Today in the homework, when we were trying to identify a polygon, you said that you couldn't have a side that had a decimal value. And I hold true to that. You cannot have a side of a polygon that is not a whole number. However, you can have an angle measure that has a decimal. You understand what I'm saying? Remember the question of the homework was, what polygon has an interior angle measure of 436 degrees? Excuse me. If I go n minus 2 times 180, remember we divided this by 180, guys? And we went 436 divided by 180 equals 2.42 equals n minus 2. I added the 2. Polygon cannot have 4.42 sides. So I just wanted to make sure we revisited that because I don't want you to get confused later or say to me, oh, Mr. Moby, you can't have degrees that are decimals. Yes, you can. You cannot have 4.42 sides to create a polygon. Polygons need full, complete sides. But the exterior angles, they can be decimals. Yes, sir. Sure, whenever you have this, I would like you to round to the hundreds. Thank you. Unless I otherwise, tell you differently, specify. Thank you, my brother. Pretty simple, right, guys? Okay, number 2. Find the number of sides for a regular polygon with an exterior angle measure of 80, what's wrong with me? Of 18. So remember that the exterior angle measure of a regular polygon is 360 over n. So I have 18 equals 360 over n. I want to solve for n, so I multiply n to both sides. I want to get rid of it from the denominator. So I have 18n equals 360 divided by 18. N equals 20. How would we call a 20-sided polygon? A 20gon. Got a question, Papa? Thank you, my brother. Pretty simple, right, guys? You're going to love this homework as well. Not many proofs. I don't think there's any proofs. It's all just math. Excuse me, I'm sorry. Okay, number 3. If each angle of a polygon is 108 degrees, how many sides does that polygon have? Okay. Now, I want you to understand something here. If they do not specify that it's an exterior angle, they're talking about interior angles here. Okay? So if each angle of a polygon is 108 degrees, how many sides does that polygon have? Remember that n minus 2 times 180 over n gives you the individual angle sum measure. So I have 108 here. So I can multiply n to both sides. So I have 180n minus 360 equals 108n. Subtract 180n to both sides. Negative 360 equals What is that? 72, negative 72, n. So I divide by negative 72 to both sides, and it should be a pentagon. So n equals 5. So that would be a pentagon. Correct, sir. Thank you. They asked for only sides, so the real answer would be 5 sides. But I just went a little further. The name of that 5-sided polygon would be a pentagon. Okay, 2 more and we're done. Find the measure of each angle of a regular octagon. Okay, n minus 2 times 180 over n gives you the individual angle measure. If they do not say exterior, they're talking about interior here, guys. So we got 8 minus 2 times 180 over n, which is 8, right? So we've got 6 times 180 over 8, and 6 times 180 equals 1080 divided by 8. So that equals 135 degrees. Now, there's an easier way to do this, though. If I find the exterior angle sum, 360 divided by 8, right, because we're talking about an octagon, right? So 360 divided by 8, each exterior angle would be 45 degrees. But doesn't each exterior angle, isn't that supplementary to each individual interior angle? So you could then go 180 minus 45, and that gives you your 135 interior angle measure. You with me here, guys? Yes, sir. The question is, do you think I should do one or the other? It really depends on you. I think this is easier, but this is very useful as well. It's good to know both, so that way you're never stuck. And last but not least, find the measure of each exterior angle of an equilateral quadrilateral. (360/4), right? Wrong. An equilateral quadrilateral is not necessarily equiangular. So there is no answer for this, guys. What would I have to have called that equilateral quadrilateral in order for this to work? A square. Be careful with the nuances of geometric vocabulary. Thank you very much. Have a wonderful day. Hope you learned a lot. God bless you, and I'll see you tomorrow, guys.